Okay, so let's get it started. So I'm so glad I'm here. It took me 20 hours to fly here, but I'm glad I'm here. From Czech Republic, Prague. So yeah, so another part of the world completely, exactly. So what we are going to do today, I'm going to talk today about performance testing, but specifically I'm going to talk about shifting left performance testing. Because when you look at industry now, everybody's talking about shift left, and then when the people start doing shift left, everybody's focusing shift left on functional testing, and maybe some parts of the organization focusing on unit testing and everything else, but everybody still wants to do it in a functional testing. And what I want to talk about today I want to talk about how performance testing can also be a shift left activity. I'm going to talk about why it's important to shift left performance testing. I'm going to talk a little bit about APIs and API economy, because these are the building blocks of our applications today. And then I'm going to talk a little bit about the tool that from the company I come from, Perforce, which is called BlazeMeter, that can actually help you in all of these activities. I'm also going to tie this to customer success stories. So I'm going to talk about some real life examples, because I know that's always popular to hear from. So you want to hear how other customers or how other organizations are doing this type of testing. So the first thing, I'm not going to talk about myself. Cameron did a good job, so thank you for that. So what I want to talk about is, everybody's talking these days that we live in API economy, and what does that actually mean? And it means that almost every application and everything we build is now driven by APIs. And what APIs allow us to do is, APIs allow us to actually expose our backend of our system with integrations to other companies or integrations with other in-house products, and actually increase the revenue through these integrations. And basically, we get more opportunities if we integrate to other industry standard tools. So basically, everything we do these days is based on APIs and how we can integrate third parties with our APIs. But in today's environment, even if the APIs touch points are growing so expandably, if you look at it from, for example, from year 2005 until today, the API integration growed around 3,000%. So basically, more and more integrations are happening every day. Many of our applications rely on third-party systems, and what is worse, it relies on the third-party systems that we cannot test against. So let's say if you work in a bank or a big bank organization, as an example, and you want to test against maybe Visa payment system, or American Express payment system, or MasterCard payment system, and you want to do performance testing against that, you will not be allowed to do that because you will be blocked to test these kind of systems. So we are going to talk about how you can overcome these problems as well. And obviously, because of all of these integrations and your brand reputation is built on these APIs working good, and also they also need to be scaled, so basically more and more customers are going to use it, there is more and more pressure on QA teams and development teams to support the APIs and API integrations. Now I'm going to give a few examples of what happens when the APIs and API integrations don't work. And some of them are very famous and some of them are less famous. I'm just going to take a few examples. Recently, obviously very well-known American pop star, Taylor Swift, she had a concerts in America, a very large tour. And basically, from the day one of opening of the website to purchase the tickets for her tour, the website crashed in a matter of 3 minutes, and there was a loss of revenue of over $300 million because nobody could purchase a ticket between the integration between the end provider of ticket system and the site where the tickets were actually being purchased. Another option is we had 1 hour downtime on Amazon during the Prime Day, for example. That cost Amazon, just that 1 hour cost them $100 million. Prime Day, basically, as you know, is when you purchase goods for a very big discounts, right? So I'm not going to go through all of these. These are public knowledge, but I want to leave you with an idea that if your APIs don't work, if you don't performance test them, if you don't test them from the scalability perspective, but also responses, downtimes, data integrity, you are going to have a lot of problems with your brand, and you're going to have a lot of unhappy customers. Okay? So now, we all know what is a shift left, and everybody always talks about shift left, and they're talking about, okay, I'm going to shift my testing practices left, I'm going to shift those processes early in the cycle, and everybody's going to do from now on, we are going to do shift left. And then, even when you talk about shift left, everybody continues to do shift left by testing end-to-end scenarios. So I'm going to take the Seleniums of the world, I'm going to take UI testing of the world, and I'm going to shift that left, and I'm just going to do that. And then later on, I'm going to focus on some integration tests. I'm going to focus maybe on some small API tests. And then eventually, my developers will probably do unit testing, and I will be happy if they do that. Now, with that kind of approach, it's very hard to introduce performance testing there, because usually performance testing is activity done on a very, very end. And there's many, many companies, and I work as a QA tester before, and performance tester as well. We do performance testing on end of all the sprints where everything is already deployed, and we do testing, and then suddenly something doesn't work, and we call development teams and tell them, okay, you have a bug. Now, they don't even remember what type of software you're talking about, because it was 8 sprints before when they implemented that part of the solution, right? So how do you now correlate performance testing, and how performance testing, if all of this needs to be done in between, how do you actually put performance testing in a map so everybody will actually do it? So the next step I want to show here is that performance testing is an activity. It actually can be activity that happens on every stage of the software development cycle. So basically, you will be able to shift left performance testing and make it a part of Agile by reversing the famous testing pyramid. So basically, in the shift left testing, usually 50% or 70% of testing should happen on the perspective of unit testing. So basically, very early in the cycle, we are all aware of that. Then 25–30% of testing should happen on the API layer. So basically, for 10,000 API tests, you can usually run one end-to-end UI test. So there's much more faster to do it on the API level. Now, when you reach the API level and you have APIs that are in isolation, but you also have APIs that are integrated, this is what we are saying we can do performance testing already. So we want to see how these small components stick together and how they work under certain different loads. And this is where the first step where you can introduce performance testing is actually introducing it on the API layer. Then you have a system under test testing and integration testing. That's another step when you can do performance testing. And then you can also do performance testing on the very end when you want to test everything end to end before it going on release. So instead of doing performance testing only once on the end of every release, we are now saying test every component, test every build if necessary, and test everything on the performance the way you would test functionality of the software as well. So that's the idea behind of shifting this paradigm on the performance testing side as well, not only on functional, not only on acceptance testing and other testing types, or unit testing as well. Okay? Now, for the last slide, before we dive into details how to do this, for the last slide, I want to put correlation what happens when API fails. So if API fails, we will lose revenue. If applications rely on this failed, we are going to have very bad customer reputation. I know for myself, when I go to, let's say, download application in Apple Store, if the application has less than 3 stars, I'm not going to even look at that application, right? So basically, we are all the same, and we will exactly do the same thing all the time. So it's very important to find these API failures on the very beginning, but it's also very important to know that your APIs will be scalable going forward. So this is where API performance testing comes in. Okay? Next slide. So next slide is actually going to talk about what are the steps to achieve a performance testing and what you need to do in your teams to actually achieve shift-left performance testing. Now, in the world of Agile, and most of us work in some Agile practices like you practice Scrum or similar aspects of Agile, it's always said in Agile that quality is an activity done by everybody. So quality is not only reserved for QA teams, it's not only reserved for developers, it's not only reserved for one activity, it's actually a merger of all of these activities. So basically, the early involvement as a first step means that QA teams and performance engineers and developers are responsible for performance and scalability of the application. So they all should actually be involved in this. Obviously, collaborative culture means if developers are building API blocks and basically they have the API definitions ready, they should work with QA teams and engineers for performance to actually understand how they can start the testing on these APIs and how they can actually build performance tests around them. So this is the cultural shift, basically culture meaning between the teams. Another option is when we are building the APIs, we need to focus that these APIs, when they are tested, will simulate the real user activity. Because usually when we test APIs, we test with one set of data. We test with static data. We test one happy path. If I ask you to raise hands and say how many of you are literally all the time practicing negative and positive testing, probably there will not be so many hands raised. So basically negative testing, chaos testing, and all this type of testing are very important these days. It's not just happy paths, everything will work fine, and customer will always use the right data to build the blocks, right? Then we need to test APIs in isolation. As soon as the API comes out, we want to see how it works. We want to test it functionally, we want to test it from a performance perspective, and then we also want to test it later on when it integrates with other APIs, because these are the building blocks of our application. Another step there is test environments. Now, we don't have test environments for, especially not for performance testing early in the cycle, because nothing is deployed to pre-production, it's not deployed in some performance testing system, and until this is all ready for us, we can wait for another 6 sprints for this to all be deployed, so now we can do performance testing. Now, this is also very late, not only because of running the tests, it's also very late for the engineering team to build the tests for that performance. So basically, what we are saying is that if we don't have environments ready, we are going to focus on simulating those requirements. So basically, this is where virtual services and mock services come into play. So this is the environments. Another step after environments, for shifting the performance testing left, you need to have the right test data. On the very beginning, you again don't have test data. Now, you cannot also use the test data that is production, even if we sometimes do, but we will never admit we do. And basically, because this is compliant by GDPR and different laws, and this is forbidden. So how do we get to the real test data, and how we can use the data also in isolation, and then basically how we can apply that data to our early tests for performance testing. So the test data is a very big important piece as much as test environments. Another step is diversity of your performance test. Usually what people do, they do spike tests or they do load tests. So basically, let's load the application with 10,000 users that can support, and look, it crashed after I load 11,000 users, right? So what are we talking about here is versatility of performance testing. Do spike tests, do load tests, do performance tests, do longevity tests, and try to build as much as possible the real user scenario, or how we usually in the industry it's actually called real-life scenarios or real user scenarios, all goal-oriented scenarios type of testing. Then, last but not least, is we want these performance tests to be integrated into our software development lifecycle. So we want this to be part of our CI/CD pipelines or DevOps pipelines, whatever we want to call it. So we want ability to integrate this with Jenkinses of the world, Azure DevOps pipelines, GitHub orchestrators, and everything else. So every time we make some major change or we deploy the new pieces of application, we want to be able to trigger performance tests the way we will trigger unit tests or functional tests. So last but not least, when we are done with all these activities, we want to monitor and get metrics. What I mean by monitoring is, I mean that we want to performance test and get metrics and see where the issues are, but we also want to reuse these tests that we can maybe monitor with them APIs or services when they go into production. So basically, we can see how it behaves once it's really deployed. So all of these activities are actually activities that you need to do to shift performance testing left. I know everybody in this room is now, okay, great, you told us what we need to do. Now the point is, can we actually do this and how we can do it, right? So we are going to talk about that, so don't worry. It's not just a theory. I will show you practical examples as well. And then I will answer questions on the end. Before I move there, I want to mention this. This is so many people get this wrong. We are definitely not talking about here that we do performance testing only as a shift left approach. Performance testing is also shift right approach. Because what you want to do is you want to test early. So you want to test performance testing once you have every build. You want to test new code. You want to test it in almost every deployment. But once it goes to production, you want to do performance tests in production as well. So I'm going to give an example here because I know audiences like real-life examples. One of our biggest customers in Europe, where I come from, is British Telecom, which is the largest telecom probably in the world, in Europe definitely, but probably one of 3 largest in the world. And it's definitely the oldest telecom company in the world. So one of the features that British Telecom is testing, they're testing every time there is a new Champions League football match which they're broadcasting on their systems. And they're also testing a Premier League football, which is the first league of football in UK. These matches that they're broadcasting, and football is huge in UK and Europe, and probably here as well, this is viewed by 6, 4, 5 million users per single match, or even more. So now they do test shift left performance testing, and they move performance testing left. But before these major events, they want to test in production as well. So what we do with them, we test in production how the streaming of these events will actually look like. So we are talking about tests that have 2.5, 3 million virtual users reaching, for example, 500,000 RPSs or responses per second. So that you cannot do on the shift left because you don't have the environments for something that robust. So that's why we move this into the production part as well. So this is just an example why this is shift left and shift right approach for performance testing. Okay, let's go next. Now, what I want to do here is, by the way, I hope you like my title. I used ChatGPT for this one, but never mind. So basically, I like it. I changed it a little bit, but still good. I like the cracking the code part. So what I want to talk about here is everything I just told you. I want to show you component by component what we actually need to test and what we need to worry about. The only component that is not going to be here, I'm not going to be talking about security aspects of security testing of APIs, which is also a big part of testing of APIs, but I'm going to talk about everything else from the perspective of performance. So what you're going to see here is the building blocks of testing the APIs and testing your services. So first of all, as we said, we need to test the services in isolation, right? So we talked about this. We have a service, it's ready, it's built by a developer. Now I want to test this in isolation. The question now comes is, okay, I have a definition of the API, developer developed it, it's not deployed anywhere, what the heck I'm going to do with it? How I'm going to use it for my testing? So that's the first question. Another question is, now we have new APIs which are integrating with other APIs, so we want to test the scalability of that integration. So that's another step. The third step is, for these APIs, I need to have a right test data that will drive these APIs. If I just test with a static approach, with singular data, and I test only happy paths as I mentioned, this will not work. So I need to have a way how to create data that will drive these APIs. And again, we said this cannot be production data, right? Our next step is, I want to be able to create tests as soon as possible based on these APIs that I need to test. So I want to have my tests ready even before somebody deploys these into some real environments where I will eventually do full performance blown testing. This is something that people like to call in-agile test creation or in-agile test development. So I want to be able to test as the speed of development, and then when I have my tests, I can reuse them later on later stages as well. Another thing is Another thing is I want to be able to test negative scenarios. So I need to know what happens if my users or my customers are using negative data or they use wrong data inside of my test. So I want to be able to do chaos testing as well. So what if customer starts using invalid Visa account numbers, or it starts using different paths than what I design in the application? How my application will react to that? Now, another thing is I want to be able to test the uptimes of my services. So I want to make sure that my services have right response times based on different even network conditions. So what if, for example, my application is used by a customer and customer has a very poor 3G or 4G network? What happens if my application has pocket losses or latencies? So what if that network condition comes? Is my application going to work properly or recover from these kind of conditions? So we need to make sure that uptime works. Not only that we need to make sure it works in testing, we want to make sure it works in production once we deploy that. Obviously, performance of all those APIs, we need to worry about. So basically, we want to see if it responds in the right time. Is it working properly based on the load and scale of application? What happens if I load 50,000 users, 100,000 users, millions of users? And then last but not least, I want to worry about data integrity. If I call that application or application service, I want to make sure that the data coming back as a response when I send a request is actually correct. So all of these aspects here, you need to worry about when you are creating performance tests and when you want to test APIs. The only thing I'm not talking about here is actually security aspects of testing, but that's a different topic. OK, so what I want to show you now is how this looks from the eyes of a tester. So you, as a tester, usually see this area here. So you have some application front end. And then in that front end, you may have some UI, or maybe you don't have a UI. Maybe you have some definitions of some APIs. So you will test through the APIs, for example. Now, if you have some application backend, and you are testing performance, what is the client backend communication? This is where your APIs are involved, right? Now, behind the scenes of that API communication, there's so many different dependencies. So first of all, you have dependencies that are in-house. So let's say different databases, you have different systems, you have different data in those databases, or you don't have data in those databases. Then you have additional dependencies in-house, which are different services, different authentication services, like, I don't know, single sign-ons of the world, auto authentications, and many, many other things. And then, unfortunately, you have dependencies inside or outside. So basically, dependencies on maybe Salesforce, on Facebook, on Google, on many, many, many other things. And then when you start testing, and you have all these dependencies, usually you see something like this. So now I want to start my testing in sprint 1 or 2. There's literally no way what I can do here, because maybe this data here is not ready, so data is not deployed. These services here, maybe it's used by somebody else, so I cannot touch them, or I don't have the right data in them. And then I have third-party services which say for me, OK, you want to hit our system with a test. Every single API request you send, we are going to charge you $1, for example. OK? Or we are not going to allow you to test at all. We tested our payment systems. We don't care, so it's all good. So this is what you get as a tester in many, many, many times. And then you need to wait so many sprints until some environment is finally ready that you can do your testing against. OK? So here is what the platform I'm going to talk about, the BlazeMeter, is actually can help you achieve all those aspects that I just talked about. So everything under one platform. OK? So what BlazeMeter is, it's a platform that started as performance testing SaaS platform, but it evolved to continuous testing platform, which has many, many different aspects. And some of the aspects of BlazeMeter is that you can have functional UI and API testing in BlazeMeter. You can also have API monitoring in BlazeMeter in production. You can have, as I said, performance testing and load testing. Then you can have mock services. So you can virtualize different services and different APIs. I will talk more about each of these components. And then we also have synthetic test data generation. So we can create synthetic data that will drive your services and your testing directly in the tool. So all of these aspects are available inside of BlazeMeter. And then we can also integrate with any CI/CD or DevOps platform. So actually, we can make it as a part of our continuous testing effort. So the first thing, before I move to the next slide, I want to say, and we are going to give you an option to create all of these aspects. Your virtual services, your environments, your test data, your scripts for your tests, with any open source you choose. So basically, if you want to build your tests for performance in JMeter, Gatling, Grindr, or you want to build virtual services directly from your Swagger or Postman collections or Open API definitions, you just need to bring them in, and the tool will take care of everything else. OK? So first, let's see how it can help with environmental problem. You remember we started when we said we have problems with environments. We need to have something ready to test against. So what we need for environments, we need test data. We need the virtual services to replicate the real environment. we need to have negative test data. And then if we want to take this to mobile, we want to talk about virtual devices as well. So all of these aspects in BlazeMeter first can be resolved by something called BlazeMeter synthetic test data. So what synthetic test data allows you to do is to supply the rules of your production data to the BlazeMeter system, and then BlazeMeter will create templates based on your real data rules. And basically, you can then use that data in any test of yours. And instead of you now spending time thinking, oh, how I'm going to create a registration form for my application. It needs to have username, password, social security number, Visa account number, I don't know, some kind of address or something like that. You will need to think of all of this. Now, BlazeMeter, based on your rules, will derive any numbers of data that you want. Once you have a template and you say, I want this data to look like this, and then you press a button and say, I want hundreds of thousands of rows of this data to be unique, the tool will create it for you. So this is something we call test data generation. And basically, this will allow you to build variety of data for your tests and then drive your tests based on this data. Another option why this is important is we can take this data and push it to a system under test as well. So not only that we can inject it into your scripts and tests, we can push it into your database or system under test. And then you will have the data consistency between the test and system under test. Very soon you will see virtual services as well. We can push this data into virtual service as well and basically make it dynamic virtual service. So every time I hit a service with a request, it will respond with a different set of data. So it's not static, which is a big problem of virtualization these days. Okay? And then everything you create on this data will be compliant to your real data, so mimicking the real-world conditions based on these data models. Now, another cool thing about this test data is that we have something called test data profiling. So what test data profiling means is that behind the scenes, we have artificial intelligence that will recognize static data in your API definitions or inside of your scripts, test scripts, and then give you recommendations how you can replace the static data with dynamic data. And then if you agree on this dynamic data that you need to replace, you'll just click a button and it will replace this static data in all of your scripts. So this is called data profiling. And to be able to do data profiling, basically the artificial intelligence behind the scenes, in this particular case for the JMeter script, it will recognize the static data and give you recommendations how to replace it with dynamic data. And then by a click of a button, you can have as many data entries to your test. So test data can work with your tests. It can also work with virtual services. And it can also be pushed to the real systems as well. So you don't need to worry about data and inventing dummy data for your testing. Another step, after you resolve the data, now you as a QA tester, you don't have a testing environment. Now, you cannot wait for somebody to deploy the testing environment for you. So what do? You move into the realm of mock services or virtual services. BlazeMeter Virtual Services allows you to create virtual service from any definition of a virtual service. It will allow you to create it manually, but it will also allow you, if you have a Swagger definition, Open API, Postman collection, YAML, whatever, you can bring it in and it will create your request and response pairs, which you will drive the virtual service with. Okay? Now, once you bring that services inside of the BlazeMeter, you can also inject the same test data generation into the virtual service. So the virtual service now will behave with the same data as your test. So when you hit it, it will reply back. I will give an example where virtual services are very useful, especially in performance testing, is what I said on the beginning. Let's say you are running a test. Again, you have your bank application. I don't know how many people here from the banking industry, but probably a lot. So basically what is happening, you are running against the banking application, and in one part you need to pay a bill and receive value from, let's say, Visa payment, which I mentioned on the beginning. Visa, as an organization, cannot allow you to test against a real Visa payment system because of obvious reasons. And also, why would you test performance of Visa payment? Because that's on Visa side and that's what they test. But you need responses from that payment system so you can proceed with the rest of your test. So basically, in cooperation with Visa, we build templates that mimic the complete Visa payment system. So now you can actually put a virtual service on that. Your performance test runs against the real application or deployed application, or if it's a shift left against the mock service, including the mock service for a third party, which is in this case Visa payment system. Now, if you virtualize the whole application or API, plus you have these third-party connectivities, you as a tester now will be able to build your tests immediately because you have your API in isolation, you have your data, you now build your, let's say, JMeter scripts against it. Now, 3 sprints, 4 sprints in advance, somebody deploys that, or DevOps team deploys that in pre-production or performance testing environment. The only thing you as a tester need to do is you need to change the endpoint not to hit the virtual service. It's now hitting the real service. But your tests are already done. So basically, you shift your test creation also to the left because you have systems against which you can create your tests. So this is where virtual services comes into play. I already mentioned these, so I don't like to read from the slides. This is actually for a giveaway, so when you have it yourself, you can actually take a look. So that's the reason for these bullet points. Now, each virtual service, once it's created, it has its own endpoint. If you run your test against that endpoint, and create your test against that endpoint, this is your shift left creation of tests. Now, you deploy in pre-production. You just change the endpoint that your tests are hitting, but your test is still valid. So you have created your testing much earlier in the cycle as well. Okay? The next step after we resolve the test data and we resolved the virtual services, now the question is, I want also to be able to test with the same data against the real system when the real system comes into play. Because eventually this will be deployed, as we said, in pre-production or performance systems. So now, because of this data consistency, we can have the same data on our front end or API layer. So basically when we are building the block. We can have the same data in our database for testing once the database is deployed. And we will have the same data in our virtual service that we created previously. So if you have a data consistency and you have a tool that can control the data consistency in all 3 layers, every time you run your test, regardless if it's a real environment or you're testing your APIs shift left, testing them in isolation as a virtual service, and then you want to combine everything together, the data consistency be across the board. And this is very important because if you have different data here, and different data in your test, this is not going to work. Okay, go next. Okay, this I will mention just very quickly. I don't want, sorry. Okay, so obviously, when this data comes in, usually it comes in as happy paths. But by just a few steps in the solution, you will be able our artificial intelligence behind the scenes will be able to help you to create negative paths. So let's say we talked about this testing of Visa payments or American Express payments and stuff. Now, what if I want to test all that, but with expired credit cards? Or I want to test it with credit cards that are on block list. Or I want to test with credit cards that don't have any funds on them. Okay? Or maybe customer gave a wrong CVC number, which is a 3-digit number on the back of the card. So with the help of AI, for every positive scenario, it will create you negative scenario data as well. So you can reuse it for your functional chaos testing or performance testing or anything else you want. You can be able to export this data everywhere as well. Okay? Now, when we have environments, we have the data, we have data consistency. Now we are talking about performance testing. So I want to performance test that. So now, in BlazeMeter, you can reuse all of we have facilities to create performance tests, but we also have facilities where we can reuse your API definitions to build a test. So let's say you have a Postman collection, and you want to run this now as a JMeter script. We have a way how to convert that to JMeter script, have all the APIs ready inside, and now we can run against these environments with this test data. What, for example, BlazeMeter will do, if it's, let's say, this is, for example, JMeter script now, it will integrate that test data automatically to the JMeter script and run it against that virtual service. And then you can scale it on the open source. You can use any tool. It doesn't matter if it's JMeter, Selenium, Grindr. I would not recommend Selenium for performance testing, but that's a different story. And you can use any API definition to build the test from as well. After you build the test, it's up to you how you are going to scale it. Are you going to shift it left and now test APIs in isolation, as I said, which we should on very beginning? But you can then reuse all the same tests in production. And BlazeMeter will scale anything from 10 users to 3 million users, or 5 million users, or any number of users that you need. So basically now you have a facility to do performance testing as well under the same platform. So we have virtual services, test data, now we have our scripts, and we have our scripts execution for performance testing. It will include also all the reporting and everything else behind the scenes. Okay, just want to make sure on time because I would like to leave some time for questions. So this is where we talk about performance testing. Now, as I mentioned, it's a very extensive platform from the perspective of test creation and what we can support to build your test. So if you want to build your tests from different definitions, you want to build them from different open source. Let's say you want to build your virtual services from, let's say, WireMock or Mockito, which is very useful tools for developers. You can bring those definitions and create more robust virtual services. So what I mean more robust virtual services is, first you saw we can build it with the different test data. We can make it used for performance or other types of testing. But we can also make these services stateful, for example. So stateful service can change state of a service depending on a request. It can also have different webhooks for the service. And then we can also drive this performance testing on different network conditions. All of that is available in these mock services I'm talking about. So it makes it much more dynamic than what, for example, Mockito will give you. But you can bring those definitions directly from development as well. And you can build tests with all of these options. So instead of you doing everything manually, it will allow you to do all this the right way. Okay? So very quickly finishing. I know we have probably 5 minutes more, right? 6? Okay, so almost there. So you remember we had all this on the very beginning? Now, with BlazeMeter, we will give you virtual services. We can also extend it to our other platform called Perfecto. I didn't talk about that, but if you want to know more, you can visit us in our booth. Perfecto is a platform where we have real and simulated mobile devices, so we can work with mobile as well. So the bottom line is, if I give you test data, mock services, virtual devices, and I allow you to create your tests, you, as a tester, have the environment to start your testing immediately, and basically to be able to shift left your testing and everything else. So the idea is shift testing left and give QA teams opportunity to work with developers in development and early stages to build performance tests. And last but not least, you can actually, once it's moved into production, you will be able to monitor reusing the same test synthetically how these APIs work. So you'll be able to monitor them in production from perspective of customer experience, uptime monitoring, performance, data integrity, and build dashboards 24/7 how my customers work with my services as well. So I think this is where we are going to stop. There was a few more slides, 2 more slides, but I'm going to skip them for now. And thanks, open floor for questions, obviously. Just give me a second. Okay.
Any questions for Sajid?
Yes, please. No, what I'm saying is that everybody in the industry is now talking shift left, shift left, shift left, right? But for performance testing specifically, there is a part of performance testing that will happen on the right side of the paradigm. So basically, when something becomes production, when something is deployed already. So basically, shift right is where the operations come in play, monitoring come in play and stuff. But performance testing also is done in that aspect as well. So this is what I'm talking about. So performance testing should be moved left, which I try to explain, but it's also activity that happens once the software is deployed as well. Okay? Anything else, please? Yes, please.
Can you handle multi-byte language, non-English language?
Of course. So for example, this test data generation can have almost any language you want. We have customers that are using it on Hebrew for Israeli market. We have customers that are using it in Mandarin for Chinese markets and so forth. Yes, for sure. Okay. Any other questions? Yes, please, sir. Yes. One more here, and then I will, yeah, go ahead, please.
One question is about the real services versus the virtual services.
Uh-huh.
Both are built on different performance characteristics.
Yes,
Is
you.
there a mechanism when we spin up the virtual service to inspect how the real services are?
Yes. So basically, there is a yes. So there is a way that you will spin these services to mimic everything a real service will do, and basically then you will drive them with, as I said, with data. You will drive them with different dependencies between multiple services because integration and stuff, and then you can create a very robust environment which you will almost get right performance data information and results once you test against them. But eventually, what I said, when this is deployed, you should do performance testing again and compare baseline to baseline. Because virtual service will never replace completely the real service. It's only there if you don't have access to something or if something is not deployed and you want to shift your testing very quickly in the process, right? Thank you. Yes, sir.
So when you talk about production, performance testing production,
Mm-hmm.
you're talking about production lightweight, not production.
So what I'm talking about production-like. But then, in that example I gave with British Telecom, the production-like is almost impossible to manage internally because you will need so many servers, so many, different permutations. Let's say this testing also includes cross-cloud testing. So let's say I need to spin the engines, which BlazeMeter allows you, in different geographics with different cloud providers. So let's say I need to test from London, Belfast. So to create a lab like that, it's very hard. So basically what the company does, it does it in a real production. Usually in godly hours of the day, from 12 in the evening to 5 in the morning, things like that, right? Anything else, please? Okay? If nothing else, I just want to leave you with this. So this is basically what we can do for you. So basically, we can simulate the environments, manage third-party dependencies, help you create your test very quickly, be able to create test data and shift testing left, and we can also help you determine how your API services work before production, but also we can monitor them in production. And we can replace all the data dependencies and all the environment dependencies for you so you can shift your testing early left. So basically, this is what I want to leave you with, and I think that's everything. Thank you so much.
Thanks a lot, mate. Well done.
Thank you, guys.